And if you are in the universe, which of course you are, right, energy is flowing all over the place. And so even if you're in the deepest, darkest areas of space, you still are at about 2.3 Kelvin. That's like the average coldest space temperature, right? So even if you built your device in that 2.3 Kelvin area, there's still some energy that's going to leak into your system. It's really hard to separate the device from the universe itself, right? So that's just like a philosophical way of looking at it. A more practical reason is this. Quantum mechanics doesn't allow for it. And we're going to study quantum mechanics before too long, but quantum mechanics basically has to do with the idea that particles are, it's kind of hard to pin down where a particle is. Particles are always in motion, even when you don't think they are. We'll talk about it later. Quantum mechanics is pretty weird stuff. But any which way, it is trippy. Okay, so let's look at a quick example. A 2.7 liter balloon. Again, we like balloons. Balloon is held at 25 degrees Celsius. And that's like a nice room temperature, 65, 70, or 68, 70 degrees Fahrenheit. What if the volume of the balloon, what would the volume of the balloon be? What would the volume of the balloon be if the temperature were lowered to, if the temperature were lowered to -5 degrees C. So obviously, if you know your relationships, you know the volume's got to go down, right? So that's something that's predictable. So we could say, well, volume 1, the initial volume is going to be 2.7 liters. The initial temperature is equal to 25 degrees Celsius, and without even thinking, I'm going to turn that into Kelvin, because I know with all of my gas laws, you find the other gas laws too, you always have to be in Kelvin. And so that's 298K. You remember your conversion there? I don't care about the decimal. I think it's 0.15 or something. Volume 2, that's what we're trying to figure out. But if we start out in liters, our answer is going to come out in liters. And temperature 2 is -5 degrees C. And again, we're going to add 273 to it to get 268K. So you just collect your data. And we said we have a relationship here, V1 over T1 equals V2 over T2. This time I want to get volume by itself. So I'm going to multiply both sides by T2. And I get V2 equals T2 V1 over T1. Okay, and so V2 equals, let's see, 268K. Or no, I'm trying to do volume first. I'm sorry. T2, yeah, T2, 268K. Times the initial volume, which we said was 2.7 liters, divided by the initial temperature, 298K. And I get a final volume of 2.4 liters. So the volume goes down a little bit. And actually, I guess we'll have some time for some of these. Okay, so first of all, I got a container here. It's 1 liter. Okay. Right now, when I push this valve, what this valve does is it connects the outside world to the inside of the container. So when I press this, and basically what it means is that the pressure inside the container is the same as the pressure out here. What I'm going to do is I'm going to plug this into a vacuum pump, and I'm going to suck the air out of it. Okay? So let's suck the air out of it. So I'll put that on there. Turn on my vacuum pump. And I'm watching a gauge right here, and it's pulling a vacuum, and I'm watching the vacuum go down, 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 so I know I'm sucking the air out. I'm going to let go of the button. When I let go of the button, that seals it off, so now this is sealed from the inside, so no air is in here. I'm going to get this off. And I'm going to take this on to this balance here, and I'm going to weigh it. Okay, so what's it? It's weigh 100 grams. Okay, so I'm getting the ballpark there, right? Okay, so it's 200 and pretty close. Pretty close. Okay, it's a little shorter than that. So I think that's getting close. That says what? That's pretty close. Let's say that's 206.35. That's probably a little heavy. Let's go. 206.35. That sounds good. 206.3. Okay. 206.3. Now I'm going to press this button, and air is going to suck in. Right. Air going in. 206.3. It's heavier now, okay? And it's heavier by 206.3. I'm going to put it up to 207.3 because I know it weighs about a gram. So basically, the air in there, in that container, 1 liter of air under this pressure and temperature weighs about a gram, okay? There is mass to it. So the first thing to realize is that air has mass, okay?
Why didn't the volume change?
Because the container is rigid.
Ah. So did the temperature change?
Temperature probably did change subtly, yep.
Ah.
Okay.
That's
So this one, again, shows some of the effects of air. So this is I've opened this up to the outside world, and if I flip this over, there's a penny and there's some paper in there. And watch what happens. Penny falls fast, paper falls slow. Why?
Because it's denser.
Air resistance, right? The air is getting in the way, or air is it's harder for the paper to fall through the air than it is the pennies. The pennies can plow through it a little better. So again, this time I'm going to suck the air out of here. Let's see what happens. Apply it back. And how close are we on the bell? 2 minutes. 2 minutes, good. I'll save this for tomorrow. We'll go look at this thing tomorrow. So I'll suck a vacuum here. Before I turn it off, I'm going to close the valve. So I close the valve now. Turn it off.